So my name is Bob Paulin. I am a senior software engineer at Snowflake. I'm a member of the ASF. I'm a committer on Camel, PMC member on Apache Tika, and a committer on Apache Felix. I have some commits against Nifi. I'm not yet on a PMC or committer there, but I'm working my way to it. I'm also a Java champion, which is interesting because we'll be talking about Python and Java here, so I have some biases, so we'll get into that. And I'm also on the Chicago Java User Group board. If you're looking for my LinkedIn information, I have the QR code there. So while I'm a senior software engineer at Snowflake, my kind of journey has been a little bit interesting. I started off probably about a year ago. Until a year ago, I was an independent consultant for about 12 years. So this talk is kind of the genesis of the journey I was on, looking for AI use cases for my customers, which were usually finance and e-commerce. Looking for a platform that could move data around, that had connectors to different things. Looking for a way to integrate that with AI models, which I had gotten a master's in way back before AI was as popular as it is now. In that, when neural networks and things like that were starting to become a little bit useful, but they were mostly for toys. Nowadays, we're seeing full-fledged LLMs do some fairly interesting things that are useful even in a business and general context. So this talk is kind of out of that research. So we're going to talk a little bit about Java, we're going to talk a little bit about Nifi, and we're going to talk a little bit about how the interaction between Python and that works. So for folks that are looking for something to do after this talk, I'm also doing a live podcast with Offheap, so it's a Java podcast. So afterwards, if you want to grab a frosty beverage and meet us just down the hall in 311, we'll be talking about open source foundations. So if you're free and you want to talk a little bit about open source, we're going to have folks there from the ASF, we're going to have folks there from Eclipse, and we'll have Aaron from Common House. So we've got a number of different representations to chat about there. So let's get back to the journey. So Apache Nifi was kind of the platform I found that seemed to offer some things that were very interesting to me as a developer. The easiest way to understand Nifi is actually just kind of to go through it and do a quick demo. So we're going to do a quick crash course in Apache Nifi, going through some data from the Chicago data portal. So in Chicago, we have a government site that has various data sets, and one of those data sets is the salary information in CSV. And some of the things that I might want to do with CSV data is I may want to take, for example, if I kind of want to look at this data raw, I may want to take CSV data, drop it into an OpenSearch database. Oh, do I have internet in here? Let's find out. It'll be fine without internet, but oh, it's downloading it, so we're not actually seeing the data. We're just getting a CSV. So if I want to open that up, what we'll see is basically names, positions, and salary information. So Apache Nifi is a web-based application, so it has what's called a canvas screen after you log in. So that canvas screen is where you're going to build data flows with the UI. Now you might look at this and be like, oh great, this is probably one of those no-code solutions where I'm just going to be dragging and dropping things to connect data together. And the reality is, yes, you can do it that way, but most businesses are also looking for things that are easy to customize, and Nifi has a number of very simple interfaces that if you need to do something custom, you can build processors and services right on top of Nifi very easily if you know Java. We're going to go through the UI aspect of it just to get a sense of how it works and what the different components are. So the first thing I'm going to do, I've got a few different process groups over here, which are basically just collections of processors and components. And we'll get into a little bit more of what that means. So for me to start things off is I'm going to create a process group, and I'm actually going to import it from a JSON file, because everything that I create in Nifi can be imported or exported as a JSON file. So if I want to move between systems, if I want to promote from dev to QA to production, I have a means to do that. So I'm going to move this Chicago salary process group in, And if I want to look at what that's doing, I'm going to open this screen, and that's going to show me my data flow. So this is my flow definition as a UI component. So within Nifi, I can define processors by simply dragging from this processor icon here onto the canvas, and then these would be created. If I double click on these processors, it'll bring me in where I can configure different properties about those processors. Those properties for a processor like this, which is called invoke HTTP, most processors will have a verb and then something that verb is acting on. I can select the HTTP method, whether it's a GET or a POST, the URL that that's going to go to in order to collect my data. I can configure timeouts and a number of things associated with that HTTP request in order for Nifi to make that call and start pulling data into the system. Most of these flows will start with something that originates where there's nothing coming into it. It'll pull from an external system, which could be Kafka. It could be a database table using a JDBC driver. A lot of different options that I can do to pull data into Nifi. The next thing I'm going to do is from this, I can drag and drop from here down to here if I want to create a connection between these two processors. Now, I've already got one called response. That's going to send the response from the HTTP request from one processor to another processor. So that's a connection that I've just created. That next processor is going to receive that response output as something called a flow file. The flow file is going to contain the response as a binary format or in a specific format that's sent. In this case, it's going to be the CSV file in UTF-8 format that's going to come across as a file, as well as some metadata attributes, which could be HTTP headers or things that are added to that processor from the request. And then finally, after I identify the MIME type is going to modify the flow file attribute to say what type of file it is. So it's going to say, okay, you got this file, it came in, I'm looking at the bytes, I'm using Apache Tika, which can tell me what type of, it can do file MIME type detection. It's going to say, oh, that's a CSV file. It's going to add an attribute that says the MIME type of this file is CSV, at which point I can send it to, well, this is called the put Elasticsearch record because Elasticsearch clients are also compatible with OpenSearch. I will have an OpenSearch search engine running in the background that it's going to dump this CSV data into. So that's kind of high level of what I'm trying to do. In order to start these processors, I can just click play. So if I right click and click start, I can start them one by one. Now this one has a little bit of a warning sign next to it. That's because I have to start a couple of things associated with it. So processors may have things that are shared between them, such as if I have a credential, like I'm trying to authenticate to Elasticsearch because I might be moving data in and moving data out of it, and it's going to use the same username and password. I may have a processor that has a controller service. So this one has a client service that is attached that knows how to hold and store Elasticsearch credentials. So if I go in and take a look at this, what I'm going to see is where is my Elasticsearch host running? If I have a password scheme implemented, this I'm just running on localhost, so I don't have any, but I can click and select different types of authentication that are supported in Elasticsearch. I can have one-to-many hosts here if I'm talking to a cluster. And all of this, I can verify to make sure I get it right by clicking the little check mark, and it will check to see if Elasticsearch is up and going and everything is expected to work. So the last one, the sniffer, I don't have to worry about that one. This should start up just fine without it. So I can click here and enable that service. There are ways just to enable everything just to go quickly, but I'm going to try to explain some of the points here. Now, what we can see is if I go back, that service is still invalid. So it doesn't have all the configuration it needs. So I have a file that's coming in. It's being detected that it's a CSV file. Well, I need to be able to read CSV to convert it into a data structure to tell Elasticsearch or OpenSearch how exactly to add that to the search index. So I have a record reader service that's going to take that input, break it down into rows, and those records can be individually added to that search index. So if I go to this service, there's a couple of different things that I can configure in there. I can say what kind of parser I want. I'm going to infer the schema from the actual file, so the rows being at the top of that CSV file will tell me what the names of the columns are going to be, and I can start that up. Now, similarly, output is handled in a writer file. So if I go back to this process, okay, we're still invalid. Well, that's because I've got one more bold field here, which is what the result looks like. And knowing Elasticsearch, it's going to come out as JSON. So if I want to keep it as JSON, I can keep the record set writer of my Elasticsearch put as a JSON base, but I can also have it be something else. So there's a variety of different record. If I go to service, I can create different types of writers if I want to change the format. We'll just start this. And now you can see I've got the red box, which means, okay, now the service is ready to start. But if I were to go back to this processor and say I wanted to create a new service, I could select different formats that I might want this to come out, whether maybe I want it to come out as protobuf, maybe I want it to come out as XML. Not everybody wants to work in XML anymore, but I have that option by selecting a different reader. So that's the output that would come out of there. You'll also notice that this processor has an arrow pointing back to it. So when I'm creating connections, I can also drag this connection back into the same box that I took it from. That's basically a retry. So if there is a failure, an error, or something that falls into a retry relationship coming out of that processor, what happens in Nifi is it's sent to that specific relationship, and if that relationship feeds back into the processor, it will retry that same flow file again in hopes that it will succeed. There's things like backoff where it can slow down the retry mechanism so you don't overload your systems. A lot of these are just kind of built in. And I can manage these relationships either by dragging and connecting them to things, or I can choose to terminate them. Like, so this is a relationship called original, which is the original flow file that comes into it. I could send the original out to be processed in some other part of the system. If I'm not going to do that, I can just terminate that, and it's just going to stop there at that processor, and it's not going to cause an error that I didn't drag and drop and send that somewhere. So those are a couple of just different things that I can do. So now that I have the controller services, the readers, and the writers configured for this processor, I'm able to start this as well. And that just leads me with this one with the red. And if I'm trying to test something, if I don't want a continuous stream of data coming in, I might just run a processor once. So I'll keep it in the stop state, and I'll select this run once. And what that's going to do is that shows it's thinking, request is made, and it comes down here, and I can see the in and the out are now at 1, which shows some data is flowing through the system. Put Elasticsearch, same deal. So if I wanted to go check, let's see. So CSV indexes, so if I want to double check, if I look at my configuration, this is all going to the CSV index in Elasticsearch. So if I want to check that, we'll refresh real quick. We can see that without configuring any schema, it's just coming straight down from the CSV. It's parsing it. It's putting it into Elasticsearch in only a few steps. So I have a data pipeline from the Chicago Data Portal to Elasticsearch in only a few clicks, which is kind of a powerful thing if you're looking for working with data. So, any questions on that? That's kind of the crash course on what Nifi does and how it works. So as you can see, like, Nifi is written in Java. All of these processors that you see and the technologies that they're using, they get packaged into the application in something called a NAR file. These NAR files are very similar to WAR files that you would throw in like a Tomcat application server, in that when you deploy a NAR file, they are isolated to a specific class loader, which means as you're building processors on the system, if you have some things that are using Apache Commons 2.15 and some that are using Apache Commons 2.2, like, you can mix and match your dependency libraries because they are running in an isolated class loader. And this is a kind of important thing if you're going to have a platform for running a number of different data processing, because you've got all these libraries and they're not all compatible. The system offers a good way of isolating these things. It's one of the strengths of the JVM is having these class loader isolations. The other thing with Nifi is it has some very simple interfaces. So if I wanted to look at what does it take to write a processor, one of the ones we looked at was this identify MIME type, right? So what you'll see in here is it's all in Java. Even though there's a UI element, I'm not writing any UI code to make this stuff work. What I'm doing is I'm creating these property descriptors, which are the configurable elements inside of each processor, like the search index, for example, was one of them, where I can define all of these names, descriptions, what's allowed to be placed in each of them. I define all of these, and then I can set them in a method for all the property descriptors. And there's a lot of cool things that I can do with these to say, well, only show this one if this is marked to true, so I can hide and show certain things depending on what that input needs to be. The other thing I can define is relationships. So what are the outbound things that this processor can send things to? So whether it's success, failure, I might have different use cases where I want to split, hey, this goes here, this goes here. I can define relationships in order to accomplish what type of outbound connections. The identify MIME type, as I said, uses Apache Tika, so you'll see the Tika code is living in here. And Tika, if you've ever looked at Tika code, it is just a huge project with a lot of dependencies because it can work on almost any type of file. All of those dependencies are isolated just to the identify, the NAR that the identify MIME type is packaged in. So I don't have to worry about Tika causing me problems because Tika only exists in a very specific module of Nifi. Unscheduled is where I put things that I want to happen at startup. So some of the validation that you saw when I turned it on the Elasticsearch can be processed in this onSchedule annotated method. So I can check things. And then finally, the other kind of notable interface is the onTrigger. And this is what happens every time the processor triggers, meaning that can be on a schedule, so it could be every 5 minutes. It could be every time a new flow file comes in. And those are the things that, this is the code that gets executed every time this processor is triggered. Any questions on the interfaces? All right, so Nifi is written in Java. I'm a Java champion. I write a ton of Java. Shouldn't I just use Java for everything that I'm doing on Nifi? Well, I've come to the conclusion after a lot of just toying around with Graal and a lot of other frameworks where you're running things on the JVM that it really does depend on your use case. So case in point, ML and data science community. So here's a very biased survey. This is a survey of Python developers asking them, what do you use for data science? So most of them, of course, say Python. There's 3% that are identifying as Python developers that say they don't use Python for any project. So I'm very curious about those people. But you can see there's a very strong community in Python that is built around data science. So writing everything in Java when you have a huge community that is writing things in Python can prove that there's some challenges. Like if you read papers on a lot of the AI development models and you see what the scientists that are creating those models, all the source code that they're publishing to their GitHubs, all the things that they're referencing in their papers, it's Python. So you don't have to depend on this super biased survey. There's a ton of example code out there on Hugging Face and a number of the different model repositories that are out there that is basically plug and play with this language. So there is some rationale why I may want to look at using Python with my JVM-based system. The number of libraries in this space, such as PyTorch, Pandas, so Onyx. Onyx does have Java bindings, by the way, so there are ways that you can use Onyx with Java that I've done, is very useful. OpenCV and NumPy is probably my number one that it's just like, man, I do not have a NumPy for Java. So whenever I'm looking to convert something over there, that is one that's especially difficult. And really, kind of the end of this point is languages and libraries evolve based on their user communities. So Eric Raymond, who is the one on the right here, wrote the book, The Cathedral and the Bazaar, And he kind of talks about this is having a community of users that are contributing things. And again, if you're scientists that are writing the papers, the people that are developing these libraries with companies based around AI and ML are working in the Python space, those libraries and APIs are going to evolve much faster than in communities where that is happening a little less, like the JVM community. I have yet to see a ton of papers on Java, unless you look at Spark, that are written on data science. There's only a few there's less than there is in the Python community. Another good thing to check out, and Guy Steele is one of the architects of the Java language. He gave a talk way back in like the 80s at Uppsala called Growing a Language, and it's literally on like projectors and slides under a projector rather than PowerPoint, where he talks about growing the Java language and kind of hits on the same thing. The people that are using your software are the ones that are evolving it, so there are reasons that you may want to mix language platforms. So all of this is to say, Apache Nifi took that as a rationale for building a Python-based plugin. So you have a couple of things to think about. So you want to interact with Python. There are some things you can do. Do we use Jython? Do we use Graal? And at the end of the day, from my personal experience, every time I have tried to run languages that are not written for the JVM, so like Groovy and Kotlin don't count because those are actually JVM languages that run on the JVM. But Node.js, Python, I'm trying to think of other languages, but those are the two that usually come to mind. Every time I've run them, if you're just writing vanilla code in those languages, it works and it's great. But once you start bringing in lots and lots of libraries and dependencies, you tend to hit those scenarios, those edge cases, right? Where some of those languages that we're trying to put a language and running in another language, it starts to break down, you get errors, and a lot of those are very difficult to work with. So one of the rationales of picking Py4j is Py4j is an interface where you are actually running a Python process. So it's running in Python on the same system that Nifi is running on. So what that means is the JVM process is actually starting a Python process. It is downloading dependencies for you if they're not there. It is then communicating with that over a socket. So the JVM objects are getting serialized over a local socket and then created as Python objects in the Python process. So if I have a flow file, the bytes of that flow file are taken as Java bytes and then converted into a Python byte array object. These objects are also then can be sent back through method binding. So if I call a method, it can call that method on the JVM. So all of this is happening through the socket. So if I call a Java method, I can get that Java method called. It's just making a reflection call to the JVM. Now, Py4j works really well for Nifi because Nifi processes each invocation, each trigger is happening within a single thread. So there's no race conditions where you're going to end up with, oh, well, something's happening in the Java side and something's happening in the Python side. It's really clean that it can return straight up into the same thread that you were working in. So this works really well in this case. The other thing that the Py4j implementation does in Nifi is it sets up a virtual environment. And if you remember earlier in the talk, I was talking a lot about class loader isolation so that if you have a plugin with different dependencies that might conflict with another plugin, that's completely okay. The Python equivalent of this is a virtual environment. So when you create a Python plugin in Nifi, it creates a virtual environment for that plugin. So the dependencies of that plugin are specific to just that plugin. So if you have one plugin to detect tables with the model, you have another one that does a chat completion, those different plugins can have different dependencies. Depending on, hey, this is only working with this version of Hugging Face, this one's only, this one requires this version of OpenCV. I can mix and match those things if I separate the plugins. The last thing that I kind of talked about is the object proxies. So there are references to the Java objects within Py4j. So if I make a call on something that is bound as a Java object, that method call can actually happen on the JVM as well. So it's not just happening all in Python. I can also have it where the method call mutates an object on the JVM because it's called in the Python script that's happening. That would be then going back through the same socket, the other direction, back towards the JVM. Then the object state is the same as you would expect it to on the Python side and the Java side because I called the Java method. Questions on this? This is kind of the visualization of how this works. Again, so your processor gets loaded. It's going to initialize a virtual environment for that Python process. It's going to start the Python process. It's going to continue to just kind of sit there and idle. As a flow file comes in, that Python process will run. As that flow file is then transformed, those bytes come back to the JVM, and then that flow file can continue into the next processor, which may be a Java processor, it may be a Python processor. All right. So we talked a little bit about dependencies. There's a couple of different ways to integrate Python-based dependencies into these projects. So the first one is some annotations you can throw in the file. I'm not even going to cover that because I would not suggest doing that. There's, if you use Groovy scripts and you use like gripe and you're just kind of loading things in the script, it's kind of the equivalent to that. So it's not a good pattern to follow unless you're just trying to do something really quick to test things out. The more popular ways, if you're a Python developer, you might create a requirements.txt file for your project. That requirements.txt file can be bundled with your Python processor so that any dependencies that you need, as it creates the virtual environment, it's going to provision that virtual environment with the requirements there. And it can do those at runtime if they're missing. So it may download them from the internet, which is cool. If you've used OSGI or other runtimes where it's like, hey, I can dynamically pull in dependencies and do things, it makes it great for demos. It's terrible for enterprises because you're completely dependent on the network and you don't necessarily know which version you're going to get unless you're very strict with how you define that file. So the last way, which is probably the most preferred way, is to use a bundled NAR file. So NAR files can also be packaged with Python files that it looks just like the Java files that we're sending over, except inside there's Python and Python dependencies. So these are pre-compiled as if you had inlined a jar file, like if you built a Spring Boot app and you're putting all those dependencies in, it pulls all the dependencies in, and then you can ship that NAR file with your application. Now, naturally, the next thing is, okay, well, wait a minute. Python might be compiling things, it might be doing things. So there are a few caveats. You got to make sure you're on same chip architecture, right? Because if I'm going to bundle all those things in there and I'm going to do it on an ARM processor and then ship it to AMD 64, that could be a problem. But at least I get very consistent and reproducible dependencies if I use that approach. And you can always create multiple NAR files for different architectures, right? Nifi is going to be running on the same thing, so you're probably going to have a JVM that's built for ARM as well. So you just have to think about those things as you're packaging your NAR files. All right, so what can I do with Python? So there are some limitations. It's not the exact same interface as for Java. It's very close, but not quite. So I can transform flow files, which is the most popular thing. So I have an on trigger, I have data that comes in, I have different data coming out. That's probably the most popular pattern that folks use. I can also use it in the same way we used invoke HTTP, where we created a new flow file. So if I am taking something, say, from outside on the internet and then pulling it in, it's the start of my process, I can do that in Python as well with a create flow file type interface. The other thing I could do, and we kind of touched on this when the inputs were going into the OpenSearch, put Elasticsearch, where we were reading record types of CSV and then writing record types. There is also a transformed record processor that if I have a flow file that has many rows in it and I want to execute on each individual row, the transform records Python processor is something that would allow me to do that. So if I'm working with like a structured data and I want to work row by row, that's a useful implementation to use there. All right, so let's start talking about some real use cases and some AI stuff to to get into why this is so powerful and useful. So if I was building a Python table detector, and this is kind of not the LLM-based AI, this is the kind of AI that has been around for a little bit longer, where it's just like, hey, I'm sending an image file, you tell me a bounding box of where stuff is. This is object detection. It's a use case that's been around for a while. But there's still a ton of active research going on this for document processing, where they found that by identifying different regions of a document and doing different parsing based on those regions, I can actually get better results than if I just send it through OCR. So this is still a very active point of research and things that people are doing. And if you look at this GitHub repository at Microsoft, all of the code is written in Python. So if I'm going to try to build a table detector out of this repository, I'm probably going to build something with the same dependencies that it has to start with, to just test out the idea, make sure it works. So I'm going to do the same thing that most of us that are doing AI development are doing. I'm going to go out to Hugging Face, or I'm going to go out to the repository and start copying and paste some of the Apache licensed code into my project and playing around and seeing if I can get it to work. This approach works very well with that model of development. But let's talk about a few kind of technical things of how table detection works, just so we understand some of the code as we go through it. The first thing you're going to do when you have an image that you're going to try to detect different things on. So the table detection, it can detect rows, it can detect columns. So if I'm trying to take an image and turn it into, say, a CSV file, I know where this row starts and ends, and I can look at individual cells. There's a lot of things I can do by just drawing over the regions on the image. But the first thing I have to do is I have to convert that image into something the model is going to understand, which is called encoding, which is where I take each pixel based on their XYZ coordinate, or their XY coordinate, or 2 dimensions, and then also put in data about the pixel color, because color can kind of matter. I want to know where the lines are. And I encode all those into floats and tensors that are going to go into a PyTorch-driven model. So I take the image, I create a multi-dimensional array of tensors, and those tensor values are based on the pixel locations and colors. The next thing that I do is I run it through the model inference. So if I have a neural network, I'm taking the encodings and I'm passing it through a neural network, and it activates different parts of the network to create output that is going to be another multi-dimensional tensor array that is going to tell me what that model is trying to do, which is I'm going to output locations of bounding boxes. I'm going to do classifications, say this is a row versus a column, but it's going to do it in a raw sense, meaning that these are just showing you which category 1 and where we think the bounding box XY coordinates are for each corner of that box. So the next thing I have to do is I'm going to try to draw these things over that image. I got to do post-processing, which means I'm going to use the image size to scale down that model output so that it fits over the image that I want to draw on to show where these things are. All right, so let's take a look at how that would look in code. So if I go to my detect image, so I have some Python code here, and this is very similar to what you'd end up finding in your GitHub repositories out there, Hugging Face, wherever you want to go. So I'm using the transformer models, which is the Hugging Face library. I'm using NumPy. I've got some JSON libraries. I'm OpenCV. I'm using Torch. Then some basic Python libraries. And what I'm doing is I'm loading the file. I'm loading the model. I'm encoding, which means I'm taking that image and turning it into to tensors, to vectors, multi-dimensional vectors. I'm then executing the encoding in the model. So this is the loaded model that I took using the table transformer. So I'm applying the encoding to the model, getting the output. I'm post-processing by telling it, hey, this is the sizes this is the image sizes that I'm putting against. And again, the transformers library is helping me out with this significantly to make sure that everything lines up again. And then the last thing I have is just a utils library that's writing over that image in order to draw the bounding boxes as well as different colors for different classifications. So not a lot of code. We're looking at under 60 lines of code there. Now, if I wanted to take something so if I wanted to run this, let's just go ahead and run the CLI. So I have got a Python detect image. I've already loaded dependencies, so we don't have to wait for those. I've got a chart of Apple just financial data, right? So this is a table, and you can see there's not a lot of lines or anything to give point of reference. If I run this, and then look in the output directory, I have a model that's drawing all of these, again, the bounding boxes over rows, columns, so I can use the intersections of these things if I want to calculate cell values and potentially use this to create a CSV out of. Now, okay, this is all great because this is all the demo stuff that somebody already wrote for me. I want to scale this up. I want to get this ready to run a bunch of images through in my enterprise. And for that, I may want to use a JVM-based process that I know I can scale up a little easier than I can a Python-based process. So I want to integrate this into Nifi. So the first thing that I want to do there is I want to define, okay, what are the different inputs that I need for my Nifi processor? So the first thing I might think about is relationships. So the annotated is what I showed you guys, is where it's writing over the image. Another thing you can do that might be helpful for creating training data sets is putting it into Cocoa format. So maybe I have another relationship that writes it as a JSON that just has the coordinates of the bounding boxes with the classifications. Cocoa is basically a data science data structure used for image annotation. So I can decide whether I want to write that in either format and create relationships around that. I might want to think about what properties I want as input. The nice thing about transformers is the table models that I'm using, I might want to make that customizable. There are actually 3 different models from Microsoft on the table transformer. One is tuned specifically to financial data. One is tuned to academic tables. And one is a combination of all 3. So the one that I'm using is the combo one. But you may want to change that model depending on what kind of data you're working with. So making that a parameter in Nifi allows me to do that at runtime. I don't have to write new code in order to use a different model. So if they come out with a new version, I can use that version immediately. The other thing I can do is I can define where my output's going. So if I want to toggle, hey, this I want Cocoa, this I want annotations, I can also create like an output type, and I can say, well, it's only one of these 2 values, so I get a nice drop down to select which output I want to come out of that. So let's take a look at how that code might start looking in Nifi. So here is, so I'm going to close the CLI project. Here is my table detection processor. So here I'm going to have I can either use my requirements file or a PyProject TOML, which is, again, like a definition where you put dependencies for the project. Here I'm going to have a source directory that's going to contain the name of my processor. And then here I have my table detection processor, which is kind of my entry method to Apache Nifi. So I'm going to start there. And I can also have supporting libraries. So the Cocoa Py and the plots util, those are the same exact libraries that I'm using in my CLI util. So I can just port those over directly if I want to do it that way. So if I go into my table detection model, you'll see I got a little bit of like boilerplate here at the top where I'm importing. Some of these are Nifi Python bindings. So these are things written for Py4j so that I know what Java objects I'm binding to here at the top. The next thing I'm importing is all of my dependent libraries like Torch and things like that I'm going to be running every time the model executes. So I'm going to have those imported here as well. So I'm writing kind of natural Python up until this point. The part that starts looking a little Java-ish is when I get down to the name of the processor. So here I'm defining a class, which, hey, you can use classes in Python. They kind of made them an afterthought, but they're there. And then I'm going to define that class as Java and what I'm implementing. So the flow file transform, that's the transform type. So I'm going to take a flow file in, and I'm having different stuff coming out. If I wanted to create, I would use a different interface at this point. I can also version it, so some of the details that you get about the processor, what version, if you want to have versioning in there, I can define that as well in the processor details. And here I'm defining my 2 relationships, one that's going to send out Cocoa data in JSON format, and another that's going to send out annotated images. So I can have my 2 relationships there. I have an init method where I'm similar to the Java method, I'm initializing my property descriptors. So this is stuff that's going to show up in the web UI. I'm writing in a Python, but it's going to eventually render on the web. So this is my model name. I could define a default value. So again, this is the version, all value. If I wanted to change that to the financial one, I could do that. I'm going to define what output type, as well as what allowable values, because I only want 2 options here. I've only got 2 relationships, so I should be specific about what I'm going to allow there. Then there's some boilerplate here about adding the property descriptors that I just defined, adding the relationships that I just defined, and then on scheduled, I'm going to do the part where I initialize the model. I only want to initialize the model once, because that's an expensive call. If you've done work in Hugging Face and you know that model download can take a while, like, I only want to do this once, not per call. So I'm going to do that in my same onScheduled that I have in the Java process. And then finally, I have my transform. So in my transform, I'm getting the flow file, I'm getting the process context. I can get attributes off of it, so I can get things like the file name if I want to keep that. I can do all of this in native Python, where I'm taking the bytes from the flow file, I'm encoding them, just like I did in my CLI script. And here you're going to see it's basically the CLI script. I'm copying and pasting this into my Nifi processor until I get down here where I'm deciding which output to use. Here I'm using the Cocoa library. Here I'm using the plot utils because I'm writing that image out. And then at the end of the day, I'm sending a flow file transform result out to the relationship that I chose with the contents of the output that came out. So it could be an image file. It could be JSON. I can decide that within my properties. So if I wanted to build this project, what I would end up doing if I wanted to use, well, I'll get to that in a minute. So any questions on this part? Why don't we actually go back to the flow and just kind of take a look. So what I end up with when I build this, though, in the distribution, I end up with a nar file. So I'm using a nar file build script, and I'll talk about that in a second. So what I would end up doing here is the built file would end up just getting copied. I would drop this in the extension directory of Apache Nifi. So if I wanted to do that, I would go to Apache Nifi under SDKs. I would go to my snapshot, extensions, and I would just copy it in here. And this has, again, all my Python dependencies. So I'm not going to do that real time because I don't want to take the time to do that, but that's how you would deploy it. All right, so let's go through a few of these things. So once I do that, and we'll just kind of go through this in the interface so that I have my flow. So let's get out of this one, and here's my detect table flow. So here I'm getting the file off of the directory, so I can define a folder that I'm reading from. I'm going to put it through the table detection processor. So once I drop that nar file in there, if I drag and drop this thing down, I will see the table detection processor that I wrote show up in the web UI. So it will find that new nar file when I restart Apache Nifi. I can put that in here. I can configure my table name, my table model name. I can decide whether I want to create annotations or Cocoa. So all this is being driven by that Python code of what relationships are available, or what output types are available. And then the relationships, I can select, Cocoa and annotations are going somewhere in the flow, so I don't have to terminate those, but I can terminate failure in the original, as I did in some of the other processors. So if I want to run this, this is going to send annotations to another file. We're just going to output the annotated file, and it'll send, if I do Cocoa, it's going to take the JSON, and I'll drop that into OpenSearch. So I can index my found bounding boxes. So if I were to drop, so it's the same Apple image. If I were to take that and drop it, so this is the file that I've defined as the input. If I drop it in here, Nifi is going to automatically discover it. Oop, it's gone. It's going to run it through this flow file through the system, and it's going to put it here. Now, I got a little warning here. That's probably because the image, I didn't delete it from the last time I tested this, so it found that the image is already there. This is a warning, but you can get all sorts of warnings and errors from these bulletins, these are called. So let's say I want to see, okay, well, what did my table processor actually do? I can click here and view data provenance, and one of the really important things that you get with Nifi is Nifi is going to track all the modifications that it makes to your data, which makes this really useful in scenarios where I not only need to know where the data came from, I need to know what system accessed it, whether the data went outside of the system to a third-party system, what it looked like when it came back. Data provenance is where Nifi tracks all of the mutations of the object. And some of this gets programmed into the on trigger, or the trigger event. But some of it you just get for free, like if an attribute changes. So if I were to look at this, I guess I need to trigger it maybe one more time. I probably waited a little too long. Let's drop another one in. We'll see if we can catch it. I have a lot of data in here, so it's possible that some of it is blowing away others. So here I can kind of take a look. Oh, that's the hex value. If I want to take the input image and then say I want to see, well, what did that create? I can see the output image, and I can see this in the web UI of what's going in and what's going out. So this is very useful for tracking changes to my activities or to my data. So we already saw these are the different scheduled events. So just like the Java interface, it has onScheduled, onStopped. The transform is the thing that does the actual actions. And the last thing I'm going to talk about is a little bit about the deployment. So the company I was at before we got bought by Snowflake was called Datavola, and we created a plugin that creates Python projects as NAR files. So this is probably the best way if you're trying to package Python up into a NAR file and then just drop the dependencies as is in. It is open source. The name may change, it may not. I have no idea what's going to happen, but it is Apache licensed open source. So it's out there, and it will still be Apache licensed in that original form. To build, if I wanted to build this, I would just basically go into my table detection. There's hatch build-t nar. If I click that, it's using a Python program called hatch to basically build, take the source, and then inline all of the dependencies that are detected as a part of that project. So that takes a little bit because it is going to download and package a rather large file of Python dependencies. Oh, get me back to my presentation. All right, so QR code's there. And then once you're done building it, you can ship it. Again, as long as you're on the same processor architecture, that hatch NAR file should work in any post 2.0 version of Apache Nifi. All the code that we went through, all of that is documented online in a GitHub repository. So if you want to try any of this stuff at home, feel free to download it. It has the same exact code that we were running, as well as all the flow definitions. So you can just import them and start with, kind of a canvas that has some data in it. If you're looking for anything on me, I'm again the QR code on the other side of the screen. Happy to talk more about Python and Apache Nifi after the talk. But are there any questions? Yes?
So Python is not particularly performant, right? So what's the need to process it paragraph? Is that a problem or not?
So serializing large data structures over, a network socket is not the most performant way to transfer it. So if you're looking to optimize that, if you want to try to compile something down into like a CLI where, you're just calling that with, so Apache Nifi does have processes that can just call commands or things. You might start a process like this and then optimize it. The other thing is you may just have multiple instances, so while it may not perform, as fast as something that's native, you might just be able to scale it horizontally. And the other thing is, Java is catching up. Even though Python right now has an edge, there's a lot of work being put into Java AI, and a lot of the work that we have been doing is converting some of these models from PyTorch to Onyx, which runs just fine on the JVM. So it is possible to do a lot of this. Onyx format models. So there is a Java library for running Onyx models. Where I find you run into trouble, though, is on a lot of the transformations that happened before and the post-processing. So like model inference is great, can be done great on Java using the Onyx format. It's all of the image manipulation and things that are happening as pre and post-processing that you're going to take some time doing that and optimizing that. Of a model in Onyx? Yeah, so actually, we were acquired 3 months ago. On the Datavola website, I actually have a blog on converting models into Onyx and inferring them. So I can give you a link to that if it's still up. Yeah, why don't we do that? Let's just check real quick. Let's see if it's still there. Okay, that's a good sign. Let's see. So if I remember correctly, it's under the blog and data and iceberg, Kubernetes. Onward to Onyx. But if you can get to the Datavolo, I go through all of the different packaging and why you run around Onyx. So if you're really looking to get that level of optimization where you're running native on the JVM, this is the kind of stuff I would go for is going onward with Onyx and see how you can get, yeah, so you can get it running there. Yeah, so it was available as of 2.0. It's evolved since then, so I would definitely take the most recent version. One of the things I had on a prior slide is they're actually looking to make it more secure, so they are working to move from pip to Vue, I think is another Python packaging tool. I have that in one of my previous slides. Yeah, so here, yep, to UV, sorry, UV. So there is some work being to kind of strip down dependencies for the Python side of it. Oh yeah, I'm sure it's finished. Yes, it's all done. Well, since everything's cached, it probably ran in under a minute. If you have a large library where it's downloading, it'll depend on network speed and all of the good things, but sorry about that? So if you can package resources in the NAR file, so there's ways to do that. Out of the box, the transformer models will, download it to a hidden directory out of the box. But if you tune your code in that, hey, maybe I'm pulling it off of somewhere in the file system, or I'm going to just try to relative path the thing when it's exploded, I could probably there's a way you could do that. It would just mean your NAR file is going to be bigger, a couple gigs. Yeah. 3.12, I think, is the lowest version. I could double check that. Yeah, I think it's 3.12. If I look at my Pi project, I think this is the minimum. This has the minimum version. 3.12. Thank you. Yes?
So some of the models in the Python, especially in the PyTorch.
Yes.
Maybe you use certain GPUs, either CUDA or you have AMD.
Yes. Yes.
How Java communicates with those kind of, I don't think there's a library for Java to communicate with GPU, CUDA or.
So I'll repeat the question. So the question is about, so when you're running a model, often you're going to want to run that model on a GPU because it's much more performant. And yes, the answer to that question is yes, it is. How does Java run on a GPU when you're running in this? So in this, it's the Python process that's running. So the Python process is going to be built on a specific architecture. Right? So if you bring in PyTorch libraries that are meant for a GPU architecture when you build it, that NAR is going to have GPU libraries in it to dynamically link to code that is running the GPU where you deploy it. Now those libraries, if there's dynamic linking, those libraries need to be installed. So CUDA being one of them, right, needs to be installed. But from that path, there's no resistance for Java because Java is calling into the Python process that's integrating. Now, if you want to do it in Java, there is also Onyx jar files that have bindings to CUDA architectures. So you can even run, if you were to convert the model to Onyx, you could run a JVM-based GPU optimized. Yeah, under the hood, that's how it's working. Yes, it's using JNI through Java to talk to the CUDA libraries because it's not native to the JVM. That's right. Nope, good question. Any other? Yes? Moving to what? Moving to Rust. No, it's an interesting question. I mean, I have not seen that in the, so the early part of the talk was talking about that's where the data science community is. So that's where a lot of the work is happening. Now, to the same argument I make for Java evolving and getting better at this, Rust has a similar initiative if it wants to get into this game. Now, to be fair, Rust is also a very low-level library. So you may even see, you can even see some of these original libraries like OpenCV might be like, hey, we're going to convert to Rust. I mean, there's a number of security initiatives where they're saying, hey, we should really get away from languages that don't have memory safety. So it would not be surprising to me to see some of those other libraries that are being used in government and trying to be in compliance with some of those initiatives, security initiatives, which may become laws, stronger laws at some point, where those underlying things turn to Rust, and then, again, Python might be calling into binaries or libraries that are compiled with Rust. Sure. Yep.
Rather than Java, probably Rust will be right, not quite, especially Python libraries, because Python is saying that the easiest way to do it, but it's not as fastest or the secure way to write the code.
Sure.
Now that you can leverage these AI-generated tools to convert any Python library into a Rust library. So I'm trying to understand, would these libraries will be going to Rust and Rust in the future, or?
That's a great question. I don't know if I have an exact answer to that other than just an opinion. I do see memory safety driving some of those things, but there's multiple options with memory safety. Now, whether, how well AI converts between languages, I have seen some hiccups with that. Like, it's not perfect yet, so I don't know that it's a slam dunk just to say, hey, Claude, rewrite everything in Rust and hope for the best. That's going to be a process, and honestly, like, you look at the runtimes and how all that are all, and Rust has a great story around that. But Java still has a great story about, multi-architecture. You write it once, run everywhere. Is still a very big thing for Java. And Rust, you're still converting down to a specific chip architecture. So we can have those debates on, okay, well, which one's the best? That's what it kind of comes down to, though. But I do see the movement in the direction that you're talking about. I do see that. Mm-hmm. I'm a no better oracle than anybody else. But memory safety is a thing. That's written into law in places that they're going to try to keep encouraging that. So I think we'll see more and more of that. Yeah. Thank you.